Okay, let's go over homework 3.2, number 3. Right? So what we're going to do is we're going to try to find all local maximum and the local minimum. So first we try to look for the critical number. Alright, let's do that. Right, before we take the derivative, I would probably rewrite this function as x plus 64 x to the negative 1. Right? Right, but and also we have to make sure that we know the domain. So domain of this function is since there's x on the bottom, so we cannot have 0. So all real numbers except for 0. So x cannot be equal to 0. Alright, so let's take the derivative. So f prime of x is equal to, alright, derivative of x is 1. Right? Then put the negative 1 in front, so it's negative 64 x to the, subtract 1 from the power, so it's negative 2. So if you rewrite that, this is going to be 1 minus 64 over x squared. And we can combine those guys together by taking the common denominator, x squared, which is x squared minus 64. Right? To find a critical number, we're going to set this equal to 0. Right? So which means that we need to set the numerator, x squared minus 64, equal to 0. Alright? Then we can just solve for x by adding 64 to both sides, which is x squared is equal to 64. Right, then we can just take the square root of both sides to find the x to be, right, it's a plus or minus, don't forget plus or minus, square root of 64 is 8. Alright, so let's do the number line. So draw a number line. Alright, then we're going to mark, so since it's not defined at 0, so I have to put a 0 there. And also negative 8, so I'll put negative 8 there. And also a positive 8 right there. Right? Then let's look at the sign of f prime. Right? So let's start with something smaller than negative 8. So I'll probably try negative 9. Right? If you plug in negative 9 here, you have negative 9 squared, which is positive 81, minus 64 is positive. The denominator is always positive, so you're going to get a positive value here. Right? Then we can try any number between negative 8 and 0. So I would try, say, negative 1. Right? So if you plug in negative 1 here, negative 1 squared is 1, minus 64 is negative, so it's going to be negative. Alright, so we can try any number between 0 and 8. So I would probably try just 1, but you can see that 1 squared minus 64 is negative, bottom is always positive, so it's still negative. Alright. Then we can try something bigger than 8, so I'll try 9. But you can see that the 9 squared is 81 minus 64, which is positive. Bottom is always positive. So therefore, I meant to say positive. Alright? So you have a positive sign there. Alright? So critical numbers are 8, a negative 8, and a positive 8. Then we can see that at negative 8, so positive turn into negative, so you have a local maximum there, right? So you have a local maximum at this point, right? And at positive 8, it's actually negative turns into positive, so you're going to have a local minimum there, right? So let's find a corresponding y value just by plugging in. So at negative 8, so plug in f of negative 8. It's going to give you negative 8 plus 64 over negative 8. So that's going to be negative 8 minus 64 divided by negative 8 is negative 8. So that's going to be negative 16. Right? So that's going to be a local maximum at negative 8, comma, negative 16. Right? So you're going to have a local minimum at positive 8. So we have to plug in 8 into the original function. So you will have 8 plus 64 over 8, which is going to be 8 plus 64 divided by 8 is 8. So it's going to be positive 16. So 8, comma, positive 16 would be the local minimum or relative minimum. Right? Don't worry that local maximum has a lower value than local minimum. You know, since it's locally, so it doesn't matter. So it is okay. That could happen. All right. Anyway, that's it. I hope that this was clear.